Lewis dot diagrams part 1. For this session, I'll be teaching you guys how to draw Lewis dot diagrams systematically. Let's start off by drawing the Lewis dot diagrams of group 4 elements using the roles on the left hand side. We'll be using methane as a first example, CH4. Okay. So step 1 is to count the total number of valence electrons needed to achieve noble gas configuration for all atoms. To achieve noble gas configuration, carbon would need 8 valence electrons. Whereas for hydrogen, because the hydrogen wants to look like helium, it needs a total of 2 valence electrons. And because there are 4 hydrogens, you multiply that 2 by 4. You get 16. The second step is to count the total number of valence electrons that are available. So for carbon, to determine the number of valence electrons, you start from the left-hand side, the first group, and you count all the way to carbon. So it's 1, 2, 3, 4. So carbon has 4 valence electrons. For hydrogen, on the other hand, it's just in group 1, so it only has 1 valence electron. And you multiply that value by 4 because there are 4 hydrogens. The next step is to subtract 16 by 8. You get 8, and later you divide that number by 2. Eventually you get 4. The number 4 tells you the number of bonds necessary to connect all the atoms in CH4 together. Usually the first atom that's written in the chemical formula is the central atom. You want to connect that to 4 other hydrogen atoms. The last step to drawing Lewis dot diagrams is to ensure that each atom has a noble gas configuration of valence electrons. So for this carbon, each bond has 2 electrons, so it has 1, 2, 3, 4, 5, 6, and 7, 8 electrons around carbon. And carbon has this filled up its valence shell with 8 electrons. It looks like neon and it's happy. For hydrogen, there's 1, 2 electrons around it. And again, it looks like a noble gas. It looks like helium, so it's happy. All the other hydrogens also have 2 electrons around it. So you've completed drawing the structure of methane. So our next example is carbon dioxide, CO2. Carbon requires 8 valence electrons to fill its valence shell. Oxygen also requires 8 valence electrons to fill its shell. So because there are 2 oxygens, we multiply 2, and we have 24. Second step is to count the number of electrons present. For carbon, there are 4 valence electrons. For oxygen, if you count from the left side to oxygen, you have 1, 2, 3, 4, 5, 6 valence electrons. So it's 2 times 6 because there are 2 oxygens. Come up with 16. Divide 8 by 2, you get 4. So there needs to be 4 bonds to connect all the atoms of carbon dioxide together. So carbon is written centrally, connected to 2 other oxygens. We used up 2 bonds so far. We have 2 more. So what we're going to do is we're going to distribute those 2 remaining bonds equally. Okay. Examine this carbon right here. There's a total number of 1, 2, 3, 4, 5, 6, 7, 8 electrons around carbon. So carbon has filled its valence shell already. For oxygen, there are only 1, 2, 3, 4 electrons. So we can go ahead and add the 5th, the 6th, the 7th, and 8th electron. For this oxygen, again, there are only 1, 2, 3, 4. We could go ahead and add the 5th, 6th, 7th, 8th electron. So now that's a complete structure of CO2. All atoms in that structure satisfy the octet rule. The next example is carbon monoxide, CO. Carbon requires 8 electrons to fill the valence shell. Oxygen requires 8 electrons to fill the valence shell. There are a total number of 4 valence electrons for carbon, and there's 6 valence electrons for oxygen. That's 10. Go ahead and do the math. 16 minus 10, that's 6 divided by 2, you get 3. So there needs to be 3 bonds to connect the carbon and oxygen together. So carbon connected to oxygen with 3 bonds. Let's examine this carbon now. There are 1, 2, 3, 4, 5, 6 electrons around carbon. We're going to add an additional 7th and 8th electron. Now carbon satisfies the octet rule. As for oxygen, there are 1, 2, 3, 4, 5, 6 electrons around oxygen. And again, we're going to add a 7th and 8th electron. So now both structures satisfies the octet rule and you have completed drawing carbon monoxide. Now we'll be drawing Lewis dot diagrams of group 5 elements. Our first example is ammonia, NH3. First step is to determine the number of valence electrons needed to achieve noble gas config for nitrogen. Nitrogen would like 8 electrons in its valence shell to complete the shell. As for the hydrogens, it would like 2. And because you have 3 hydrogens, it's just 3 times 2. And you get 14. Second step is to determine the number of valence electrons in nitrogen. So nitrogen is located right here. We'll go ahead and count from the left-hand side to determine the number of valence electrons. There's 1, 2, 3, 4, 5 valence electrons for nitrogen. Now for the hydrogens, there's only 1 valence electron, so it's just 3 hydrogen times 1 valence electron. So you have a total of 8 electrons. We do 14 minus 8, you get 6. You divide that by 2, you get 3. So you need 3 bonds to connect all the atoms in ammonia together. First draw the nitrogen out, and you can have 3 bonds coming out of the nitrogen. And at the end of each bond, you place hydrogens. Let's examine the number of electrons around nitrogen right now. There's 1, 2, 3, 4, 5, 6 electrons. You could go ahead and add the 7th and 8th electron. This right here, these 2 electrons together is known as a lone pair, so we just added what we call a lone pair to this nitrogen. Okay, so if we count all the electrons around nitrogen now, we have 8 electrons, and it has filled the valence shell, the outermost shell. It's very happy. It looks like a noble gas now. If you consider the hydrogens, this hydrogen right here has 2 electrons in this bond. So there are 2 electrons around the hydrogen. It looks like a helium. It now has filled up the valence shell, the outermost shell of hydrogen. So again, it's happy as well. So you've completed drawing out ammonia. The next example is nitrogen triiodide, Ni3. Nitrogen would like 8 electrons to fill its valence shell. And each iodine would also like 8 electrons to fill its valence shell. So it would be 3 times 8. And that's 32 electrons. The second step is to determine how many valence electrons each of the atoms have. Nitrogen has 5 valence electrons, whereas for iodine, we could go ahead and count iodines located here. So you start off by counting from the left-hand side to iodine to determine how many valence electrons there are. So you start 1, 2, and you skip all the transition metal elements. Now you have 3, 4, 5, 6, 7. So iodine has 7 valence electrons. You multiply 3 by 7, and you get 26. If you do the math, it's a 6 divided by 2 now, and you have 3. So you need 3 bonds to connect all the atoms for the nitrogen triiodide. So you have nitrogen, 1, 2, and 3. You have iodines at the end. Okay, again, let's consider how many electrons are around nitrogen. There are 1, 2, 3, 4, 5, 6, and finally 7, 8 electrons around nitrogen. So nitrogen is really happy now. You added a lone pair. For iodine, there are only 1, 2 electrons surrounding this iodine. Go ahead and add 1 lone pair, so that's 1, 2, 3, 4 electrons now. Add another lone pair, now it's 5, 6 electrons. And finally add the third lone pair, and that's the 7th and 8th electron. So now this iodine filled up its valence shell, and it's really happy. It looks like a noble gas now. You could do the same for the other two iodines. Just go ahead and add 3 lone pairs per iodine. And now you've completed drawing the nitrogen triiodide structure. The last example that we'll be doing on this slide is nitrogen gas, which is N2. Nitrogen would like 8 electrons to fill its valence shell. Because there's 2 nitrogens, you multiply by 2. So you get 16. The second step is determining the number of valence electrons in nitrogen. There's actually 5 valence electrons in nitrogen. Again, you multiply by 2 because there's 2 nitrogens. This is equal to 10. If you do the subtraction, it's 16 minus 10, which is 6. Divide that by 2, and you get 3 bonds. 3 bonds are necessary to connect the 2 nitrogens together. So let's go ahead and write nitrogen with 3 bonds to nitrogen. Now consider the number of electrons around this nitrogen on the left-hand side. There are 1, 2, 3, 4, 5, 6 electrons. Let's go ahead and add the 7th and 8th electrons. Now the nitrogen on the left-hand side has satisfied the octet rule. You could do the same for the nitrogen on the right side and just add 2 electrons. So this right here, because both nitrogen has satisfied the octet rule, you've drawn the Lewis dot diagram for nitrogen gas. We'll be drawing the Lewis dot diagram for group 6 elements now. Water will be our first example, which is H2O. To fill up the valence shell for hydrogen, you need 2 electrons, so it's just 2 times 2. To fill up the valence shell for oxygen, you need 8 electrons, so you tally that up, and that's 12 electrons. Second step, hydrogen has 1 valence electron, so for 2 hydrogen, there's a total of 2 times 1 electrons for its valence shell. For oxygen, there's located right here, there's 1, 2, 3, 4, 5, 6 valence electrons. 12 minus 8 is 4. You divide that by 2, you get 2. So you need 2 bonds to connect all the atoms within the water molecule together. So for oxygen, draw 2 bonds to connect the hydrogens. Now let's examine the number of electrons around oxygen. There's 1, 2, 3, 4, 5, 6, 7, 8 electrons around oxygen. Now it's happy. We filled the valence shell. For hydrogen, you have also filled the valence shell. There's 2 electrons around both hydrogens. Our next example is hydrogen sulfide, which is H2S. 2 electrons are necessary to fill the valence shell of hydrogen, and 8 electrons are necessary to fill the valence shell for sulfur. So that comes out to be 12. Hydrogen has 1 valence electron. There's 2 hydrogens, so it's 2 times 1. Sulfur, located right here, has a total number of 1, 2, 3, 4, 5, 6 valence electrons. That's 6. Tally that up, that's 8. 12 minus 8 is 4. You divide that by 2. You have 2 bonds that are required to connect all the atoms within H2S together. Okay. For the sulfur, there are 1, 2, 3, 4, and you can add the 5th, 6th, 7th, 8th electron around the sulfur. So it filled its valence shell with 8 electrons, and so did the 2 hydrogens with 2 electrons each. Our last example is methanol, which has the formula CH3OH. Carbon requires 8 electrons to fill its valence shell. The hydrogen requires 2 electrons, and because there's 3 hydrogens, it's 3 times 2. The oxygen requires 8 electrons, and that hydrogen requires 2 electrons. If you add all those numbers up, it's 24. The second step is to determine the total number of valence electrons that are within this methanol molecule. So carbon has 4 valence electrons. The hydrogens, the 3 hydrogens each has 1. So it's 3 times 1. The oxygen has 6, and the hydrogen has 1. If you add those numbers up, you get 14. 24 minus 14 is 10. You divide by 2. So you need 5 bonds to connect all the atoms within the methanol molecule together. First step is to write that carbon. And you connect it with 3 hydrogens. So we used up 3 bonds so far. For the last bond that's on carbon, we could connect it with an oxygen. Now for the 5th bond, we can't connect it to the carbon anymore because the carbon already has 8 electrons around it, right? Because it has 4 bonds. So each bond contains 2 electrons, so it's 1, 2, 3, 4, 5, 6, 7, 8 electrons. So carbon has filled its valence shell. You can't give it any more electrons. So the only way to add that last bond is add it to that oxygen species. So we'll add that bond and that hydrogen connected to it. Now, we've added all 5 bonds. The carbon here has completed its valence shell with 80 electrons around it. All the hydrogen has also completed its valence shell. It has filled up its valence shells. The only atom that has not filled up its valence shell is this oxygen right here. There's only 1, 2, 3, 4 electrons around the oxygen. We'll add the 5th, 6th, 7th, and 8th electron. Now this oxygen has filled its valence shell, and you completed drawing the methanol molecule. So our next example is drawing the Lewis dot diagram of H2NOH. Hydrogen requires 2 valence electrons to fill its shell, so it's 2 times 2 because there's 2 hydrogens. Nitrogen requires 8 electrons, oxygen requires 8 electrons, and hydrogen requires 2 electrons. So that's 4 plus 8, 12, 22. Hydrogen has 1 valence electron. There's 2 hydrogens times 1. Nitrogen has 5 valence electrons. Oxygen has 6 valence electrons, and the last hydrogen has 1 valence electron. So adding all that up, it's 2, 7, 13, 14. 22 minus 14, that's 8 divided by 2. So in order to connect all atoms together, you require 4 bonds. Nitrogen will be the central atom. It will be connected to 2 other hydrogens. Nitrogen will use another bond to connect to 1 oxygen. So we used up 3 bonds so far. To connect the last hydrogen, we add a bond to the oxygen and we write H. So now let's examine this nitrogen to see whether or not it has filled its valence shell. Nitrogen has 1, 2, 3, 4, 5, 6 electrons around it right now. We can add additional 7th and 8th electron. Now nitrogen has a filled valence shell. The hydrogens all have a filled valence shell with 2 electrons each. The only atom that does not have a filled valence shell right now is the oxygen. There are 1, 2, 3, 4 electrons. We can add the 5th, 6th, 7th, and 8th electron. Now all atoms have a filled valence shell, and that is your final Lewis dot diagram for H2NOH. Next example is oxygen gas, that's O2. Oxygen requires 8 valence electrons to fill its shell, so it's 8 times 2 because there's 2 oxygen, giving us 16. Oxygen has 6 valence electrons. Multiply that by 2, that would give you 12. 16 minus 12 is 4. Divide by 2 gives you 2. So in order to link the 2 oxygen atoms together, you need 2 bonds. This oxygen on the left side has a total number of 1, 2, 3, 4 electrons. You can add the 5th, 6th, 7th, and 8th electron to fill up its valence shell. The oxygen on the right side has 1, 2, 3, 4 electrons. You can add a 5th, 6th, 7th, and 8th electron to fill the valence shell. So this is your final structure for oxygen gas. Our last example is ethanol. The formula for ethanol is CH3CH2OH. First step, carbon requires 8 valence electrons to fill its valence shell. The hydrogen requires 2 valence electrons. There's 3 hydrogens, so it's 2 times 3. Next carbon right here requires 8 electrons to fill its valence shell. The 2 hydrogens, so it's 2 times 2. And the oxygen requires 8 electrons to fill its valence shell. And lastly, you can add that 2. So it's 8 plus 6, which is 14, 22, 26, and that's 34 and 36 electrons. Next step, carbon has 4 valence electrons. Each of the hydrogens have 1 each, so 3 times 1. The carbon has 4, and each of the hydrogens has 1 valence electron. The oxygen has 6 valence electrons, and the hydrogen has 1. So that's 4 plus 3, 7, 11, 13, 19, and 20 electrons. 36 minus 20 is 16, and you divide that by 2. So you need a total of 8 bonds to link all the atoms in ethanol together. We'll start off by writing the carbon, and we link that up to 3 hydrogens. Use 3 bonds so far. Next step is to draw the second carbon, and we link this carbon up to additional 2 hydrogens. So far we used 1, 2, 3, 4, 5, 6 bonds already. We have 2 bonds left. Those last 2 bonds will link the oxygen to the carbon and a hydrogen to the oxygen. You'll notice that these carbons right here, this carbon has 8 electrons around it, and this carbon has 8 electrons around it. And all the hydrogens each have 2 electrons around it. So they have filled up their valence shell already. The only atom that has not filled up its valence shell is this oxygen. So there are 1, 2, 3, 4 electrons so far. We'll add the 5th, 6th, 7th, and 8th electron. So this is your final structure for ethanol. So we'll be drawing the Lewis dot diagrams for group 7 elements now. For fluorine gas, F2, fluorine requires 8 electrons to fill its valence shell, so that's 8 times 2, because there's 2 fluorines, and you get 16. Second step, fluorine is located right here. So there are 1, 2, 3, 4, 5, 6, 7 valence electrons for each fluorine. So that's 7 times 2, and you get 14. Subtract 16 by 14, you get 2, divide that by 2, 1. So 1 bond is required to link the fluorine atoms together. If we examine this fluorine on the left-hand side, there's 1 bond, so this fluorine only has 2 electrons around it so far. We can add a 3rd, 4th, 5th, 6th, 7th, and 8th electron. The fluorine on the right-hand side has 1 bond, so it has 2 electrons around it right now, so we'll go ahead and add the 3rd, 4th, 5th, 6th, 7th, and 8th electron, and that is your structure of fluorine gas. Next Lewis dot diagram we'll be drawing is hydrogen fluoride. So hydrogen requires 2 valence electrons to fill its valence shell, whereas the fluorine requires 8 electrons, so that's 10 electrons. Hydrogen contains 1 valence electron, and fluorine has 7 valence electrons, so that's 8. So 10 minus 8 is 2, divided by 2 is 1. 1 bond is required to link the hydrogen and fluoride together. There's 2 electrons around the hydrogen, so that's happy. Hydrogen has filled up its valence shell, but for this fluorine, there's only 2 electrons around it. So you need to add the 3rd, 4th, 5th, 6th, 7th, and 8th electron. So you've completed drawing hydrogen fluoride. The last molecule, carbon tetrafluoride, CF4, carbon requires 8 valence electrons to fill its valence shell, and each of the 4 fluorines requires 8 electrons each to fill its valence shell, so you multiply 8 by 4, and that would be 40. Second step, carbon has 4 valence electrons, whereas each of the fluorines has 7 valence electrons, so it's 7 times 4. Now, you subtract 40 by 32, you get 8. 8 divided by 2 is 4. So you require 4 bonds to link up all the atoms in carbon tetrafluoride. Carbon is written centrally. It's connected to 4 other fluorines. Carbon has 8 electrons around it, so it has filled its valence shell. This fluorine right here only has 2 electrons around it, so we can add 3 lone pairs, and now it has 8 electrons. We can do the same for the 3 other fluorines. This is the final structure of carbon tetrafluoride. Now we'll be drawing the Lewis dot diagram for nitrogen trifluoride, which is NF3. Nitrogen requires 8 electrons to fill its valence shell, and each of the 3 fluorines also require 8 electrons. That's 32 electrons. The nitrogen has 5 valence electrons